Remember, this is real, and it's happening right now. At this very moment, you're hurtling through space at 107,000 kilometers an hour. That's 30 kilometers every second. Today, we're here. In 4 weeks, we'll be at the equinox. Here, the beginning of spring. During our trip through the solar system, we are escorted by our neighbors, the planets. This week, let's look beyond the planets to the stars. They're infinitely further away, but we can still use them as guides. One star always tells us which way is north. Polaris, the pole star, easy to find, 5 widths behind the Great Bear, Big Dipper. The pole star is aligned with the Earth's axis. All night, the stars seem to whirl around the pole star as it remains motionless, naturally since it's in line with our axis of rotation. So the pole star is a practical and reliable landmark. Christopher Columbus used it when unknown lands. He decided to cross the ocean on the 28th parallel. Every night, he measured the angle of Polaris. As long as his quadrant showed 28 degrees, he knew he was on course. He hadn't drifted south or north. He was following the 28th parallel. Do what Christopher Columbus did. No telescope, no mathematics. Just look at Polaris and imagine the movement of Spaceship Earth, rotating on its axis, always pointing at the pole star. But that's not quite true. Over 26,000 years, it draws a circle. Imagine the Earth's axis jutting out of the North Pole, stretching to infinity. It meets the pole star. From one millennium to another, other stars become our northern star. 12,000 years ago, for the cavemen, it was Vega. 5,000 years ago, Thuban. That's when the Egyptians built the pyramids. They aimed a shaft north, and what they saw at the end of that shaft was the star Thuban. Just to the left of the Great Bear, the Big Dipper, while today, tourists see the pole star. Thuban pole star. This is the angle the Earth has swung through in 5,000 years. We can all imagine months and years, perhaps even a century, but to imagine 5,000 years, you have to look at the angle between Thuban and pole star. As we travel on our orbit, we see the stars move slightly from one week to the next. Constellation of Orion, easily found to the south. With its head, 2 arms, 2 feet, and belt. The slight daily shift of the stars is completely lost in the enormous sweeping motion of the Earth's rotation, changing our field of vision every hour, making it revolve from night to day and back to night. Look at Orion every night at the same time. You'll see the celestial sphere rotating at a snail's pace. Of course, the celestial sphere doesn't exist. It's an imaginary dome where the infinitely distant stars seem to sparkle. And of course, the celestial sphere doesn't turn. It's us on Earth who travel around the sun once a year, 360 degrees in 365 days, 1 degree a day. So every day at the same time, we look 1 degree left and see that the stars have drifted 1 degree to the right. This week at around 9 p.m., Orion is due south. In 2 weeks, it'll have slipped a little to the right, and in a month, a little further. The stars move 1 degree every day, and each day they pass 4 minutes earlier. 1 degree in space, 4 minutes in time. Space and time meet. Since the beginning of this cruise, we've stressed the difference between the planets nearby and the faraway stars. But there's one star smack in the middle of our planetary backyard: the Sun. Yes, the Sun is a star. All those twinkling dots beyond the planets are stars, distant suns. Galaxies are billions of suns. Seen from the Earth, the planets look like stars, but you only have to look at the Sun to be dazzled by the difference. The Sun shines, while the planets only reflect a part of the Sun's light. The Sun sends us light and heat, a gigantic nuclear reactor. In fact, the solar system is the Sun, and next to nothing. All the planets, Earth included, make up only 1,000th of the solar system. The Sun is too big for us to grasp. The entire Earth-Moon system, including the Moon's orbit, would fit inside the Sun. Yet this enormous Sun is a relatively small star. And if we compare our Sun to other stars, our little Earth disappears completely from the screen. In the constellation of Orion, Betelgeuse is the largest star we know. It's so big it could easily swallow our Sun along with the Earth in orbit. All that would fit inside this star. We're familiar with the dimensions of the infinitely small, atoms with nuclei and spinning electrons. We also know the dimensions of the infinitely large, the universe and the stars. Now there's a new dimension: our solar system. We are the first generation who can grasp and explore it. Our journey's aim is to let you experience this new dimension.